right, hey guys. A little bit different right now since we're not at school. I will have these videos posted for each of your lessons. The nice thing about them will be you can pause them, you can re-watch them, you can rewatch an example, you can fast forward through examples if you already know what you're doing. But we are going to start up with chapter 8, which is systems of equations and matrices. Systems of equations will be nothing new. You've done them in Algebra 1, you've done them in Algebra 2. Hopefully, if you don't know what I'm talking about right now, it'll start to come back to you in these first couple of sections. The first one we're going to look at right now is graphing and substitution. So a system of equations, remember, is two or more equations involving two or more variables. So our variables in this case are just x and y. So the variables are just x and y. And then A, B, C, D, E, and F are just numbers. Okay, so they're just representing whatever number might be there. When we have a solution of a system, that's just going to be a basic ordered pair x, y that is going to make both of your equations true. So if we have an ordered pair 1, 2, that's a solution. When we plug that into both equations, we're going to get the same number on both sides of the equal sign. So when you find a set of all solutions, find the set of all solutions of the system of equations, you are solving a systems of equations. So really, we're just solving for x and y, and we're always going to write that answer as an ordered pair. Okay, so first thing we're going to do is we're going to look at this system of equation up at the top. We've got x plus 2y equals 9, and negative 2x plus 3y equals 10. And in numbers 1 and 2, we just have ordered pairs. And what we need to determine is if those ordered pairs are solutions of that system of equations. So, sorry. So all we're doing is we're plugging it in to both equations. So in number 1, 1 is our x value, 4 is our y value, so we're just going to plug that in for x and y in both equations. So 1 plus 2 times 4, is that equal to 9? Well, 1 plus 2 times 4, 2 times 4 is 8. 1 plus 8 is 9. That one works out. And then we just plug it into the second equation. So negative 2 times 1 plus 3 times 4, is that equal to 10? Negative 2 times 1 is negative 2. 3 times 4 is 12. Negative 2 plus 12 is 10, which is what we needed. So since both of those equations work, it's going to be a solution of that system of equations. Okay, so I'm going to go ahead and ask that you pause this video and work out number 2. You're just plugging in that ordered pair for both equations to see if it's going to be a true statement or not, if you're going to get the same thing on both sides of the equal sign. If you do, it's a solution. If you don't, not a solution. Okay, so take a second and go ahead and do that. Okay, so we're just plugging in 3, negative 1 for x and y. So 3 plus 2 times negative 1, does that equal 9? Well, 2 times negative 1 is negative 2. 3 plus negative 2 is 1, which does not equal 9. So since that already doesn't work in the first equation, we can go ahead and say that it's not going to be a solution. So it doesn't have to be, you don't have to show both of the equations. If it doesn't work in one, it doesn't matter if it's going to work in the other because it's already not a solution. Okay, so that's just checking to see if an ordered pair is a solution or not. So next thing we're going to do is we are going to get into our first way to solve a system of equation, which is solving by graphing. I don't care if you use your calculator to help you graph these equations or not. That's your choice. However, if you do, just keep in mind you're going to have to make a detailed graph in like homework, quizzes, tests, whatever. So make sure that you're labeling points and not just drawing 2 lines for your axes and then a line through for your equation that doesn't actually tell me where that line is. So when you're graphing these, if they're not in slope-intercept form, get them in slope-intercept form. It will make your life a little bit easier. And you're just graphing it like normal. So in number 3, we've got y equals negative x plus 3 and y equals x plus 1. When you're solving by graphing, what you're looking for is where they intersect. So whatever that point is where they intersect, that's going to be your answer. So we're just going to make our graph. My first one, y equals negative x plus 3. I'm going to start up at positive 3. My slope is negative 1, because remember that negative is like a negative 1 in front of that x. And since it's a slope of negative 1, it's just down 1 over 1. So that's my first equation. And then my second equation, y equals x plus 1. I'm going to start up at positive 1. My slope is just 1. So I'm going to go up 1 over 1. It really doesn't matter how many points you include. As long as you have that point where they intersect, you're going to be good. So let me change that color. So this point right here is where they're intersecting. So that's going to be our answer. So our x value here is 1. Our y value is at 2. So we just write that as an ordered pair. Always make sure you're writing those as an ordered pair. If you just write x equals 1, y equals 2, technically those are the right x and y values, but you're going to lose points for not writing it as an ordered pair. So you always want to make sure that you're doing that. Okay, so we're going to do the same thing in number 4. We're solving by graphing. So we're just going to make our graph. So my first equation, y equals 2x minus 4. I'm going to start down at negative 4. And then I'm going to go up 2 over 1 since my slope is 2. And I'm just going to keep doing that for a few points. I'm going to connect. Now, if you're more of a visual person and you need to change colors so you can kind of tell the difference between your graphs, by all means, use colored pencils, crayons, whatever you got. So I'll go ahead and switch colors for my second equation, y equals negative 1/2 x plus 1. So I'm going to start up at positive 1. And then I'm going to use my slope, which is negative 1 over 2, negative 1/2. So down 1 and over 2. And I'm going to connect those points. We'll pretend that all three of those points connected. And then that point right there where they both intersected is going to be my answer, which was at 2, 0. So x is 2, y is 0. If you're ever not sure if you're getting the right answer, you can plug those into both of the equations as long as you both equations work out, you're good. Okay, so we're just graphing, finding where they intersect. Okay, so same thing in number 5. We're just solving by graphing. In this case, if you don't have your equations already written so that they are set equal to y, you just want to get them set equal to y. So you just want to solve for y. So for x minus y equals 3, I'm going to subtract my x to the other side. So I have negative y equals negative x plus 3. And then I'm going to divide by a negative on both sides so that I'm using y equals x minus 3. And then for the second equation to get y by itself, I just have to subtract an x on both sides. So I'm going to set my graph up. My first equation, y equals x minus 3, I'm going to start down at negative 3. I have a slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1, and so on. And then my second equation, y equals negative x plus 3. I'm going to start up at positive 3. I have a slope of negative 1. So down 1 over 1, down 1 over 1, and so on until they intersect. So we're intersecting right here at 3, 0. So that's your solving by graphing. Again, you can use your calculator to help you graph them. That's fine. Remember, if you aren't sure what those points are, if you graph it in your calculator and then hit second of that graph button, it will pull up a table and give you some ordered pairs for your graph. All right, now we have 3 different types of solutions that we can have with systems of equations. We can have one solution, we can have infinitely many solutions, and we can have no solutions. So if we have one solution, your slopes are going to be completely different. Okay, so they're not going to be the same at all. And they're only going to intersect at one time. Your your lines are only going to intersect at one point. So it's going to intersect right there. You've got 2 different lines, 2 different equations. If we have infinitely many solutions, your slopes are going to be the same. You're going to have infinite intersection points because basically your 2 equations are going to be the same line. So for example, you might have one equation that says 2x plus y equals 3. And then you might have another equation that's 4x plus 2y equals 6. So they don't look the same, but if you were to solve for y and simplify everything down, you would end up with the exact same equation. So if you look at that second equation, those values are just doubled. So 2x times 2 is 4x, y times 2 is 2y, 3 times 2 is 6. So it's going to simplify down to the same thing, same exact line. And then if you don't have any solutions, your slopes are the same, but they're not going to intersect. So you're going to have 2 parallel lines. So Parallel lines always have the same slope, but they have different y-intercepts. So we could have a line that was y equals negative 1/2 x plus 2, and then y equals negative 1/2 x minus 4. So we've got that same slope of negative 1/2, but they have different y-intercepts. So they're going to start at different places, but they're going to have the same slope, so they're never going to actually intersect each other. All right, so substitution. We're going to learn 3 ways to solve a system of equations. We've already done graphing, we're about to do substitution, and then in the next section, we will look at elimination. None of you will all agree on which way you think is the easiest. Most of you will probably not pick graphing because unless it lands perfectly on a whole number like ordered pair, like 1, 2, negative 5, 4, something like that, it can be harder to figure out what that intersection is if it's not a whole number. Substitution and elimination, half of you will prefer substitution, half of you will prefer elimination. In the grand scheme of things, I'm not really going to tell you, you have to solve this way. If you are really good at elimination, I'm just going to let you solve these by elimination because that's what's going to make you successful. If you're really good at substitution, just solve substitution because that's going to make you successful. So whichever one makes more sense to you, whichever one is easier for you, go with that. So substitution, you're going to, if one is not already, you're going to solve one of your equations for one of the variables. Does not matter which one, make it the easiest possible option that you have. Step 2, you're going to substitute the expression in step 1 into your second equation. Step 3, you're going to solve the equation in step 2. And then step 4, you're going to use your answer from step 3 to solve for the other variable. And again, answers always written in an ordered pair. So we're starting a little bit easier. In number 6, I went ahead and gave you an example where both of them were already set equal to y. Now, if you have equations where you're both of them are already set equal to the same variable, you're essentially just setting them equal to each other. So you could look at it as saying, okay, well, I'm taking my 2x minus 1 and I'm plugging it in for that other y value since it's equal to y. So 2x minus 1 equals negative x plus 5. Okay, so this right here, what I just starred, that's your step 2. We didn't have to really do step 1 because they were already both solved for a variable. So now we're on to step 3. We're solving the equation. So I'm going to add an x to both sides. And then I'm going to add a 1 to both sides. So I've got 3x equals 6. I divide by 3 and end up with x equals 2. That's step 3. So now step 4, I'm going to take that answer I got in step 3 and I'm going to plug it back into one of my other equations, one of my original 2 equations to solve for the other variable. It does not matter which one you plug into at all. So I'm just going to plug it into the first one. So y equals 2 times x, which in this case is 2, so I'm plugging in that 2, minus 1. Well, 2 times 2 is 4. 4 minus 1 is 3. And then last thing you do is write that answer as an ordered pair. Okay, so if you need to solve one of your equations for a variable, you do that first. You substitute it into the other equation, solve that equation, use that answer to plug it back in to one of your original equations to get your final answer. Okay, so in number 7, x minus y equals 0, 2x plus y equals 9. It doesn't matter which variable you solve for, and it doesn't matter in which equation you use. Make it the easiest thing you can. Since the first equation has a 0, I'm just going to solve for x because I can just add that y to the other side. So I end up getting x equals y. And what I'm going to do is I'm going to plug that y in for x in my second equation. So I've got 2y plus y equals 9. 2y plus y gives me 3y. I divide by 3 and get y equals 3. Now, I'm done through step 3 now. Now I'm on step 4. Use my answer in step 3 to solve for the other variable. I could take that y equals 3 and I could plug it into my first equation. I could plug it into my second equation. Or I can plug it into the equation where I solved for one of my variables. I would do that. Okay, I've already said that x has to equal y. So if I were to just say, okay, well, I'm going to take that and I'm going to plug it in up here, then it's much easier to solve for. So x equals y. I'm going to plug that 3 in for my y. X has to also equal 3. And then I'm just writing my answer as an ordered pair. Okay, so if you missed something or a step in that I did in number 7, back up this recording and rewatch that again before we move on to number 8. Okay, so we're doing the same thing, but we took it a little bit farther. Okay, so these are going to be slightly harder to solve for, maybe, depending on which variable you choose. My suggestion would be to look at our first equation in number 8. So to look at the 8x plus 4y equals negative 2. And then I'm going to choose to solve for y. It really doesn't matter. We're going to have a fraction either way, but I think it'll be a little bit easier if we solve for y. So I'm going to subtract my 8x, and then I'm going to divide by my 4. So negative 8 divided by 4 gives me negative 2. Negative 2 divided by 4 gives me negative 1/2. Okay, so now I'm going to take this negative 2x minus 1/2 and I'm going to plug it in for that y in negative 12x plus 5y equals negative 8. Okay, so I'm going to solve this for x. So first thing I got to do is I got to distribute my 5. So negative 12x minus 10x minus 5/2. So I'm going to combine my like terms. Oops. So negative 22x minus 5 over 2 equals negative 8. I am going to add my 5/2 to the other side. And again, I'm keeping things in fraction form because if we don't get a whole number, we want to make sure that we leave our answer as a fraction. And then last thing I'm going to do is I'm going to divide by negative 22. So when I simplify everything down, I end up getting 1/4 for x. And now I'm going to plug that into this equation here where I solve for y to make it a little bit easier than if I were to plug it into one of my original two. You still can plug it into one of your original two. That's totally your choice. So y equals negative 2 times 1/4 minus 1/2. So negative 2 times 1/4 is going to give me negative 1/2 minus 1/2 is going to give me negative 1 for my y value. Which gave me 1/4 negative 1 for my ordered pair. All right, so I would encourage you to go ahead and pause this and try number 9 on your own. It is kind of tough. It's similar to number 8 in that we're going to have to deal with fractions no matter what variable we solve for. But I think that if you really just sit there and concentrate on your steps and what you're doing, I think you guys will do well. Okay, so I would encourage you to go ahead and pause it, try working it out on your own, and then hitting play again to see how you did. Okay, so I'm choosing to look at my first equation, and I am going to go ahead and solve for x. So first thing that I'm going to do is I'm going to add my 3y to the other side, and then I'm going to divide everything by 2. So I've got x equals 3/2 y plus 8. And I'm going to take that and I'm going to plug it in for x in my second equation. So 3 times 3/2 y plus 8 plus 4y is going to equal 7. So I'm going to then distribute my 3, which is going to give me 9/2 y plus 24 plus 4y. I'm going to combine my like terms. Which gives me 17/2 y. And now I'm just solving my equation. So if I subtract my 24, I end up with negative 17. You can either, remember when you have a fraction, you can divide by that fraction, or you can multiply by the reciprocal. Either way, when we do that, we're going to get negative 2 for y. And then I'm going to plug that negative 2 back into this equation where I solved for x. So 3/2 times negative 2 plus 8, 3/2 times negative 2 is going to give me negative 3 plus 8 is going to give me 5. So I write that as an ordered pair and end up with 5, negative 2. And hopefully you ended up with that as well. Okay, so same thing here in 10 and 11. It's just a matter of solving for a variable and then plugging it into your next one. So I'm going to solve for y in the first equation. So I'm going to subtract a 4x and then divide by negative. So I've got y equals 4x minus 2. I'm going to plug that in for y in my second equation. And now I'm just solving that equation. So I'm going to distribute my negative 1/2. When I add combine my like terms, 2x minus 2x is 0x. So I'm just left with 1 equals 1. So when your variable completely cancels out, you just have to say, okay, was whatever I was left with a true statement? So is 1 equal to 1? Hopefully you are saying yes right now. So when it's a true statement, when it's 1 equals 1, 5 equals 5, -4 equals -4, 0 equals 0, whatever, when it's a true statement, that's when you end up with infinitely many solutions. And then in number 11, we're going to do the same thing. So I'm just going to we'll just solve for 4y, for y in the first one. So I'll add a 5x to both sides, divide by 4. Which will simplify down to 7/2. And then I'm going to plug that into y in my second equation. I'm going to distribute my 4, which is going to give me 5x minus 14. I combine my like terms. 5x minus 5x is 0. And I'm just left with -14 equals 4, which hopefully you are saying is not a true statement. When we have something that's not a true statement, that's when it becomes a no solution. So when the variables are gone and it's a true statement, infinitely many solutions. When your variables are gone and it's not a true statement, no solution. Hopefully that helps. That makes sense. When we look at number 12, a small business invests $8,000 to produce a new candy bar. Each bar costs $1.20 to produce and sells for $2. How many candy bars must be sold before the business breaks even? Okay, so this is known as a cost revenue problem. So your cost is how much per bar times the number of bars plus your initial cost. So generally when we write an equation for cost, we have it C equal to whatever it is. So C equals the cost of our bar, which was $1.20 to produce. So $1.20x plus the initial cost. So they invested $8,000. So that's what we are adding on to that cost equation. And then our revenue is going to be how much we are charging for these candy bars. So revenue is generally denoted with R in the equation, and it's just the cost of our candy bar times however many candy bars we sell. So the candy bars are $2 times however many we sell, so times X. Now, if we want to break even, we want these two equations to be equal to each other. So when you're solving a cost revenue problem and they want to just know you're going to break even, you're just going to take that cost equation and you're going to set it equal to your revenue equation. So 2x equals $1.20x plus 8,000. So we're just going to solve that equation. So we're going to subtract our 1.2x to the other side, which is going to give us 0.8x equals 8,000. And then we're going to divide that 0.8 on both sides, which is going to give us 10,000 for x. So to break even, we have to sell 10,000 candy bars.